Okay, so let's go over this thing. So, number one, find the solutions for the following polynomial equation. So, just to recap, if I'm thinking about finding the solutions, right, and my polynomial equation says equal to 0, then I want 0, right? And what we were doing with finding the solutions before is we would have something that looks like this. And then we'd say find the solutions. And then we talked about the man, now I can't think of the rule. Oh yeah, it's the zero product. I'm just gonna say rule instead of property because I'm trying to save space. So we talked about the zero product rule. And what did that mean? That meant that it doesn't matter what I have. If I'm multiplying and one piece of that multiplication problem is zero, then the whole thing is zero. So in this case, I've got this polynomial times this polynomial. So if one of those two polynomials equals zero, then my whole thing equals zero. Does everybody follow where I'm going? Okay. So I look at these two polynomials and I think, well, what will make x plus 5 0? So then I set it equal to 0, and I find out that x equals negative 5 will make that 0. And then what will make x minus 3 equal to 0? That is x equals positive 3 will be 0. So what are my solutions for this? Is x equals negative 5 and 3. Those would be my solutions. Now, what comes with this is, wait a minute, Ferg, that doesn't look like this, right? Yeah. This doesn't look like that. So can anybody think of what's the first thing we need to do to make it look like this? Does anybody got any ideas? We factor it. Because what have we been doing for a while? We've been taking these polynomials and factoring them and breaking them down to pieces, smaller polynomials that we multiply to get it. So what I need to do first is factor that. Now, in all honesty, some folks might be able to look at this and think about, you know what, I could tell you what number needs to get put in there to give me 0 for that. And some people can do that. I am not necessarily one of those people. So if we factor it, it'll break down to something that looks like this, right? And then we can find the solutions. So, so our first step is to factor this. So what's my A? What's my B? And what's my C? So I got my X, A times C, and B. A times C is what? 9. And what's my B? So now I need to think of what two numbers multiply to give me 9. But when I add them, I get 10. 1 and 9. If that wasn't something that you could think of, you just put 9 here and you write down the factors for 9. 1 times 9, 3 times 3. And I figure out which pair works. So now that I figured out which pair works, I rewrite the problem, but I replace 10x with these two numbers. And then I do factor by grouping. So I look at 3x to the second power plus 9x. What do those two terms have in common? 3 and x. Now, if that's not something that you could have seen, then what you need to do is you need to do prime factorization. You need to break each term down in its prime factors. You guys remember what a prime factor is? A prime factor is a number that the only way you can get it through multiplication is multiplying that number times 1. For instance, 3. 3 can't be broken down anymore except by 3 times 1. So this right here breaks down to 3 times x times x. That's how I get 3x to the second power. 9x is 3 times 3 times x. And then I look to see what they have in common. They got a 3 and they got an x. So then I pull those two things out. X, right? There we go. And so I've got 3x that I pulled out. And now I just write what's left over. There's an x here and a 3 there. So x plus 3. And then I do the same here. I've got 1x or x plus 3. What do they have in common? 1. Because frankly, they have nothing else in common. But you always have to pull something out. So in this case, I'm going to pull out a 1. And then I got the same thing that's there. So now that I did the factor by grouping, I rewrite my stuff and then I'm done. So I've got 3x plus 1. That's my first factor. And then I've got x plus 3. Usually we write it in the reverse order. We write what's in the parentheses first, and then we look at what's left. 3x plus 1, that's my first factor. X plus 3 is my second. So now I take that, because that's this thing factored, and I just smack a 0 on the end. I say, okay, what are my solutions? Well, there's one that's easy to tell. What's the solution? Or what's one of those solutions? -3. Does everybody see what I'm talking about when I say -3? Thank you, ma'am. Because I take x plus 3, set it equal to 0, and then I solve that equation, and I get x equals -3. Now, this is a little more challenging, but it's not really that much challenging. The thing is, excuse me, this first, well, not the first, excuse me, the second one was a one-step equation. One step, done. All I had to do was add or subtract 3 from both sides, and I got my x equals -3. Well, here it's a two-step equation. So I got 3x plus 1 equals 0. First, I got to subtract 1 from both sides and get 3x equals a -1. Then, bless you, then what I need to do is I need to divide, well, let me write it down here because I'm running out of room. I divide each side by 3, and I get x equals -1/3. So my answers, or my solutions, x equals -3, x equals -1/3. That's what I was looking for that problem. So what did we do on it? We had to factor. Once we factored, then we used the zero product rule to find the solutions. That's what we did for this first problem. Factor and zero product rule. So this next one, find the solutions with multiplicity. The first thing is you need to know what multiplicity is. So we talked about what multiplicity is. Can anybody tell me what multiplicity is? Just broken down simply, is how many times your answer appears in your equation. I mean, there's a bunch of different, more technical definitions we could say, but that's the easiest one. For instance, I'm going to just focus on this thing right here, this piece, and then I'll explain multiplicity. All right? So this is a similar problem to the one we just passed. Okay, I've got several things that are being multiplied times each other that are set equal to 0. And looking for the solutions, that means I take each piece and I set it equal to 0. So let's look at this piece. And a matter of fact, I'm going to label them A, B, C, D, E. So let's look at that B piece. That's x minus 7. I'm going to set that equal to 0. What kind of equation is that? It's a one-step equation. Excellent. So I'm going to add 7 to both sides, and I get x equals 7, or positive 7. Now we talk about the multiplicity. How many times does it appear in this equation? Could you say that a little louder, please? Now, where did you get that from? It's to the 6th power. So what the heck does that mean? It means that x minus 7 to the 6th power is x minus 7 times x minus 7 times x minus 7 times x minus 7 times x minus 7. And so tired of saying it, x minus 7. So if I wrote this problem just out totally, there'd be 6 of those. And this answer, x equals 7. What about this one? X equals 7. What about this one? X equals 7. So how many times does 7 appear as one of my answers? 6. So I would write x equals 7 with multiplicity, or a multiplicity if you want to get technical, but I'm trying to save space. Multiplicity of 6. And that's how I do that. And I do that for each A, B, C, D, and E. Each one. So now I got to erase this bottom stuff because, like I said, I'm running out of room. I'm probably going to rearrange this thing because it looks like there's not enough room to write this stuff. So the test, I may have to play with some space, or maybe make it 3 pages just so I got enough room. So anyway, let's now that I showed you with that one piece, let's go back to A and let's break each piece down. So the first one, I've got x squared minus 16 equals 0. Does anybody recognize that? What does that look like? I couldn't hear you. What does that look like? We've talked about it a ton of times. Starts with a D. Say it again, ma'am. This right here is the difference of squares. Remember, difference is the answer to a subtraction problem. X to the second power is a perfect square because it's x times x. 16 is a perfect square because it's 4 times 4, right? So I can factor that to x plus 4 times x minus 4. Now, I'm going to put a pin in that because look right here. I got an x minus 4 right there. Does everybody see what I'm talking about? Does everybody see what I'm talking about? So if I have one x minus 4 here and I have another one there, what do you think my multiplicity for x minus 4 equals 0? Add 4 to both sides, and I get x equals 4. What do you think the multiplicity is for that? 2. So my answer right here is x equals 4 with multiplicity of 2. Because x minus 4 appears twice. Well, x plus 4 appears once. So what do you think the answer to that is? See, there's no more x plus 4s. So x plus 4 equals 0. I subtract 4 from both sides, and I get x equals negative 4. And now I'm really running out of space with multiplicity of 1 because it only appears once. So now that's A, that's D, and that's B. I still got 2 more left. So let's see, x minus 6. There's no exponent, so it's only there once. So I add 6 to both sides, because that's what kind of equation? One step. X equals 6 with multiplicity of, let's see, of what? Of what? 1. And then my final one, so that was C. This is going to be A and C. Now, I'm not saying that you have to write it with the little letters in there. I'm just trying to label the stuff so you can see it more. So, last but not least, I got x minus 12 to the third power. So that's x minus 12 equals 0. I add 12 to both sides. And I got x equals 12 with multiplicity of 3. And that was E. So, like I said, I might have to give you some more space to write, but that's what I'm looking for there, is each of these answers written like that. Does anybody have any questions? Couldn't hear you. No, there is no setup. That's it. It's finding solutions. You could write, I mean, because I need to know the multiplicity of each solution, it's not like I could write my answer like this because I have to have the multiplicity for each individual one. Now, if you wanted to do something, I guess you could say like x equals 6 and x equals -4 with both with multiplicities of 1. I guess you could say that if you was trying to save space, but I think it's a little asinine to do that. So anyway, one more time for the cheap seats. Does anybody have any questions on that? Okay, so now let's talk about the remainder theorem. The remainder theorem says that when I look at my divisor, I get my D. What's my D for this divisor? It's 3. Now, why is it 3? Because when I'm getting my D, I look at x minus D, and I look at my divisor. And then I just take out the D. X minus 3, x minus D. So D equals 3. And to get your remainder, you want to do f of D. Now, what the heck does that mean? That means that I plug whatever D is into the function that I have, or I plug this 3 into that equation. No, you need to do the remainder theorem. Now, you could do the synthetic division to check it if you wanted to, but the whole point of this problem is making sure you understand the remainder theorem. So that's going to be 3 to the third power minus 4 times 3 to the second power plus 5 times 3 minus 6. 3 to the second, 3 to the third power is what? It's 27. -4. Well, first off, what's 3 to the second power? 9. So I've got -4 times 9. What's -4 times 9? It's -36. And then I've got 5 times 3, that's 15, minus 6. Well, I could add the positive numbers and put the negative numbers together, or I could say these two equal what? -9, and these two equal +9. So I get 0. So the whole point of this problem is for you to show the remainder. Well, you don't need that. Just to show the remainder theorem and that you get a 0. That's how you show that this is a factor. Because how do you show what's a factor? Well, a factor is something that you use to multiply to get something. So like if I got 16, 2 times 8, 2 and 8 are factors. So what I'm asking you to do is say, show me that 2 is a factor of 16. So how do I show that? I take 2 and I divide it into 16. And if it goes in there evenly, then it's a factor, right? So how do I show that something goes into something evenly with division? Well, I look to see if I have a remainder of 0. If I have a remainder of 0, then I know it goes in there evenly. That's what we use the remainder theorem for in this case. We use the remainder theorem. We check to see if it's 0. Does anybody have any questions? Another one. Okay. So now, use the remainder theorem to find the remainder for the following. Again, the remainder theorem. So I look over here, what I'm dividing by. What's my D? So remember, my D needs to be in the form, or my divisor needs to be in the form of x minus D. Is that in the form of x minus D? No. So I need to take x plus 2 and change it to x minus a -2. Now it's in that form. So what's my D? -2. So -2 is what I plug in here. So I plug in -2. So I got 3 times the -2 to the third power, minus 5 times -2 to the second power, plus 7 times the -2 plus 9. So let's break this down each piece. I got 3 times a -2 to the third power. What's -2 to the third power? That's -8. It's important that you get your signs right, because -2 times -2 is +4. But +4 times a -2 is -8. Then I've got negative 5 times negative 2 to the second power. What's negative 2 to the second power? It's a positive 4. And now I've got a positive 7 times a negative 2. What's that? That's negative 14. And then plus 9. So 3 times a negative 8 is negative 24. Negative 5 times 4 is negative 20. Negative 14 plus 9, well, yeah, negative 14 plus 9 is negative 5. And then I just add all those numbers together. They're all negative, so I just combine the numbers. So what's that, negative 49? That's my remainder. That's what the remainder theorem does for you. It finds the remainder. Factor. X method and divide the following. What would we do here? Divide the following. Yep. Well, I'm suggesting you do synthetic. So what's my D for this problem? 2. And read out my coefficients real quick. 1, 0. Very important. What's 0 in this case? Placeholder. You got to know, because x to the third power is there. We're looking for x to the second power that ain't there. So we need to put 0 as a placeholder for that. And then we got what else? And then negative 7. So blase de blee, and you get your you do your division, and that's what you do. Real quick for this one, you got your A times your C and your B. What's my A? 2. What's my B? And what's my C? So I'm going to have 2 times 5, that's 10. And then I'm going to have 11. What two numbers multiply to give me 10? But when I add them, I get 11. 10 and 1. So then now I do the next step. 2x squared plus. So instead of putting 11x, I put 10x plus 1x and then plus 5. And this looks similar to that other problem, doesn't it? Because right here, they have nothing in common. All I can pull out is a 1, right? So if I pull out that 1, I'm going to have x plus 5. Because of the way factor by grouping works, I know that I should have x plus 5 in my parentheses if I did it right. So what can I pull out here? 2 and an x. And if I pull out 2 and an x, I got x plus 5 left. So then what happens when I factor this? I get x plus 5 times 2x plus 1. It doesn't say solve it. It isn't equal to 0. It's just factor. So that's factor. That's my answer there. And then finally, because I got like a minute left, bring the 1 down. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. 6 plus 4 is 10. 2 times 10 is 20. And then I got a negative 7 and a positive 20. That's a positive 13. Now this one I need to finish. So I got x to the 0 power, x to the first power, x to the second power. So that's x to the second power, because there's a 1 right there, which we don't have to write, plus 2x plus 10. That's my all of those. And then I also got to put my remainder in there. 13 over x minus 2. And that's my answer. That's my name. Show me.